Welcome to this tutorial series. In the previous section, we configured our Ghost Helm chat, tailored it to our needs, and pushed the code to our GitHub repo. Now that we have Argo CD running, our continuous deployment process becomes even more effortless. All we need to do is create an Argo application that will deploy and continuously sync our applications with Git. We also need to create an Argo project to define the scope of what this application can manage. I've already created these resources, so let me walk through them. I created these two files. The first one is the Argo application, and the second one is the Argo project. Let's start with the Argo project. An app project defines a project in Argo CD to group applications. So under this app project is where we will deploy all our applications. We are going to use namespace Argo. These are the cluster resource whitelists, and we give it a description Ghost block project. Another important part is the destination. It pretty much specifies where applications can be deployed. Here we allow any cluster and any namespace, which is a bit too broad, but we're making it simple. Server is the server destination where the applications will be deployed. This pretty much is the local Kubernetes address. And since Argo CD is deployed on the same Kubernetes server where all our applications will be deployed, this local Kubernetes address will work. Source repo specifies allowed repositories for deployment. Here as well, we specify any repo. Next is the Argo CD application. The repo URL points to our GitHub repository, which is right here. Target revision specifies the Git branch to track, and for us is the master branch. We don't have any other branches. Path defines the location of the Helm chat inside the repo, so we know it's the Ghost folder. Finally, the sync policy. Prune is equal to true, deletes resources that are no longer in Git. This means that, for example, if we delete a service from our Ghost Helm chat in the GitHub repo, the service will be automatically deleted in our Kubernetes cluster. Self-heal equals to true restores resources that are modified outside of Git. So the opposite, if we delete a service in the Kubernetes cluster, because in our GitHub repo the service is still defined, it will be automatically recreated. Let's first apply the Argo project. And next we apply the Argo application. But right after that, our Ghost application will start deployment. So let's log into Argo CD first. We can see the project we just created in our UI with all the configurations we gave it. Now let's deploy the Ghost application. We can see in the UI that it automatically started deployment. Let's track it. Already looking pretty good. The PVCs got created, secrets, service, and everything else is looking good so far. We can also track the progress directly from the command line. Like I said before, the Ghost Helm chat creates two things, the Ghost application and a dedicated MySQL server. Quick heads up, what you're seeing here is just one slice of my complete course, where I guide you step by step to master Argo CD on AWS EKS, build production-ready Kubernetes pipelines with Helm, and set up real-world observability using Prometheus, Grafana, and Fluentbit, so you can 10x your DevOps SRE skills and stand out as the go-to expert on your team. I've added a special discount just for YouTube viewers, so go grab it in the link in the description before it's gone. Remember, we enabled MySQL metrics in the Ghost Helm chat, and so we can now see after deployment that the Ghost MySQL metrics service is running. The Ghost MySQL metrics service collects and exposes the database performance metrics like the query rate, connection stats, and many others for monitoring with Prometheus and other observability tools. But we can actually port forward this service to see the metrics in real time. With the kubectl port forward command, I'm exposing this service locally to me on port 9104, so I can access it right here. These are live metrics coming from the MySQL deployment. In the comment sections, what we'll do is we'll use Prometheus to scrape these metrics and use Grafana to actually visualize and create beautiful dashboards for them. We'll also create alerts that will be sent to our Slack channel, so stay tuned. Let's stop port forwarding and check on the status of our Ghost application deployment. It looks like it's done and everything is running perfectly fine. Our application is now exposed on this load balancer. And we can actually hit the admin URL on this path, Ghost. From here, we'll be able to log in and configure our website as an administrator, but we'll do that in the comment sections. One cool thing about GitOps is the self-healing feature. The self-healing feature in GitOps ensures that any manually deleted or modified resource are automatically restored to match the desired state in Git. Let's test this by deleting the Ghost service. This is the Ghost service, and note that when we delete it, our application will pretty much be down. Refresh, and you can see that our application has actually crashed. But within a few seconds, Argo CD will detect that there's a missing resource and it will recreate it automatically, restoring access to the end users. So if you see the running services, we can see that the new service has been recreated for us. We should be able to access our application on this URL once the new load balancer has been provisioned. Let's wait for it to become active. Nice! The service recreation happened because we enabled self-healing in our Argo CD application configuration. You can see it right here. Sync policy, self-heal equal to true. This is a very powerful feature that ensures our deployments remain consistent with the Git repository, preventing accidental or unauthorized changes from affecting availability. Ready to 10x your DevOps or SRE career? Grab my full step-to-step course where we build this entire project. The same kind of project landed me my first 6-figure SRE job. Special YouTube discount in the link in the description. Don't miss it.